Hi and welcome to a Kirby Maths video which is all about factorising into a single bracket. A factor is a number or a letter which goes exactly into another number or an expression. And the word factorise, if you see that in a question, it means that you're going to have to put a bracket in. Sometimes you might have to put two brackets in, but in this video we are concentrating on inserting a single bracket into our expression. And what factorising does is, despite being quite tricky to do, it does actually simplify the expression. Okay, so I'm going to do an example, and the first example is 2x plus 4, and we are being asked to factorise that. Now, in the past you might have come across factor trees, and if I did a little factor tree for 2x, it would be 2 times x, and if I did one for 4, it would be 2 times 2. And you can see from having done those two factor trees that the number 2 is in both of our factor trees. And that means that that is the number that is going to go on the outside of our bracket. And then on the inside of our bracket, we're going to put the remaining x and the remaining 2. And happy days, we are adding here, so we don't need to worry too much about any signs. So x plus 2 in there, and we got the 2 on the outside of the bracket from those 2's in the factor trees. If I do another example, 5x minus 15. Factor tree for 5x would be 5 times x, and here 5 times 3. 5 is in both of these, so it is the 5 that is going to go on the outside of the bracket. And inside the bracket we have the x and the 3, and they're being subtracted this time, so x minus 3. And what we're actually doing is we're kind of undoing multiplying out to bracket. So if I looked at this bracket, if I multiplied this bracket out, if I expanded it, I would have 2 times x, which would give me 2x, and 2 times 2, which would give me 4. Same here, 5 times x is 5x, 5 times 3 is 15. But we're doing the reverse of that, so we just leave it like this with the bracket in it. When you are asked to factorise, you are usually asked to factorise fully, and that means you need to take the largest number you possibly can outside the bracket. If we look at this example, 4x plus 16, and I do a factor tree here, starting off very simply, 4 times x, and here 4 times 8, 4 times 4. I can split these two down again to a 2 and a 2, and here the same, a 2 and a 2 and a 2 and a 2. But I'm looking for the largest number, so it's this row of factorising that I need to have a look at. The largest number that goes into 4x and goes into 16 is 4, so that is going to be the number on the outside of my bracket. And then inside I would just have an x, because that's all that's left on this row, and here a plus 4, and it's the 4 which is the largest number. If I had put just a 2 on the outside, because there clearly is a 2 in all of these, if I had used, say, this one and this one, I could have 2 on the outside of the bracket, and then I would have 2 times x inside the bracket. And here I would have 2 times 2 times 2, which is 2, 4, 8, so plus 8. But my test would be, can I factorise this again? A 2 and an x. This is a 2 and a 4, which is a 2 and a 2. And again, I can take another factor out of this, which means that this was not the largest number that would come outside. So this is not fully factorised, and you won't get all the marks in a test for that. Okay, not a minus, it looks like a minus. So not fully factorised. You're always looking for the largest number. And I'll just do one final example where this time we might take a letter outside of the bracket. So if we start off with x squared plus 3x, we factorise this, that's x times x, and factorise this bit, which is 3 times x. This time there's not a number that goes into both of them, but there is a letter which goes into both of them. Oops, I didn't write that. Okay, and the letter is x. So it is that that's going to go on the outside of our bracket. So the x goes on the outside of the bracket because that's in both of them. And then inside the bracket we have x and a 3. And finally, just if you've got more than one letter, just have a quick look at this. This is much more difficult though, so don't worry if this is a step too far. It's the simple ones at the top that we need to really focus on. But if we had x squared y plus x y, if I did a factor tree for this, I would have x squared times y, and then here an x and an x, and here an x and a y. And I'm looking at what's in both of these expressions, these parts, these terms, these parts of the thing I'm trying to factorise. So I've got an x in both of them, a plain x, and I've got a plain y in both of them. So that is what can come on the outside of the bracket, an x and a y. And then inside the bracket I've got an x left over. And here it looks like I haven't got anything left over, but I can't put 0. So I put a 1 here because I've got 1 times x and 1 times y. So this becomes a 1. And like I said, this is a particularly complicated one, but you could double check it by multiplying it out, which would be x times y times x, which would be x squared y, and then xy times 1, which would be xy. This one is about as difficult as it gets with a single bracket. So just to recap then, we're trying to get the largest number that is common to both of these terms outside of the bracket, and then what is remaining from our factor tree goes inside the bracket. Sometimes when the numbers get bigger, you can take a factor outside, but it's not the largest factor. You want to have the largest factor outside the bracket. And remember that the largest factor doesn't always have to be a number. Here there was an x in each of these terms, and that meant that an x was the factor that came outside the bracket. Okay, thanks for watching.